Section 6.5, length of curves. In this section, we are going to find the arc length of the function y equals f of x from x equals a to x equals b. By the slice and sum technique, will give us the formula. The arc length equals the definite integral from point a to point b of the square root of 1 plus the derivative of the function f squared with respect to x. Let's see how we come up with this formula. With the slice and sum technique, we divide the interval from point A to point B into n equal subintervals, and each interval with the width of delta x, and assume we look for one segment length. As you recall, the distance between 2 points is square root of x2 minus x1 squared plus y2 minus y1 squared. And the change in x is delta x. The change in y is delta y. The d, or the distance of one segment or one arc length here, is the square root of delta x quantity squared plus the delta y quantity squared in the square root here. And next, we divide all by delta x squared within the radical and multiply by delta x squared as well. We'll get delta x outside of the radical. In the radical, we have 1 plus delta y divided by delta x quantity squared. As you know, the delta x is the same as differential x. So we have square root of 1 plus the delta y divided by delta x quantity squared multiplied by dx. This is the length of one segment. The d of one segment I. So we have many of them. We take the limit of the sum of all line segments together. That means we take the limit of the square root of 1 plus delta y over delta x quantity squared dx as n approaches infinity, or as delta x approaches 0. The delta y over delta x is the slope of the tangent line. As we take the limit as the delta x approaches 0, it becomes the derivative or the y prime. That will give us the arc length as a definite integral in the form of integral from the lower limit a to the upper limit b of square root of 1 plus the y prime squared with respect to x.